Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x, and what we have is x sine 3x, right? So what we've been given is dy by dx, and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y. So that's my y. Now when I notice that my y has got two parts inside it, right? One is an x, the other is a sine 3x. And so, what's the best method? I know that my y is not in a very simple format whose antiderivative I know from first principles or any of the identities we have learned so far. So, can I solve it by the method of substitution? The answer is no, because I'm not in a position to relate sine 3x with x dx in any form. So it looks like I have a function of the type udv, right? And how do I integrate a function of the type udv? We know from integration by parts identity that my integral of udv equals uv minus integral of v du, right? So let's write that down. So there we are. Now the key here is to identify what is our u and what is our dv, right? So let's assume that my u equal to x and my dv equals sine 3x dx. Now, from my dv, can I figure out what is my v? With this particular substitution of u and v, the answer is yes. And when I go into my v du, which is the second part of the integration by parts expansion, I notice that my du becomes dx, and my v will also be available to me. And I notice that my vdu also is in a very simple format, right? So therefore, this is probably a substitution with which you can solve this particular problem, right? Now, before we go ahead and solve this problem, I want you folks to look at what if we did the other substitution, right? Which is my u equals sine 3x, and my dv becomes equal to x dx, right? So getting my uv is not a problem because my dv is x dx. So I will know what is my v because my dv is in a format whose antiderivative I know from first principles. But then when I go to my v du, right, I will again have an expression of the format integral of v, which is x squared by 2 times du, which is minus cos 3x into 3, right? So what happens in this particular substitution, you notice that I have my uv, but my integral of v du is still in a very complex format, right? So therefore, the better substitution is what we did earlier, right? So let's go back to the original substitution what we made. So this is the substitution that we made. My u equals x and my dv equals sine 3x dx, right? So what is my v? My v is nothing but minus of cos 3x by 3, right? And I'm not adding my constant here. I'll reserve my constant towards the end, right? So this is my v, and I will also need my du. I know that my u equal to x, therefore my du equals dx, right? So I go back to my integration by parts, and I have my LHS equal to integral of x times sine 3x dx. My uv is now, my u is x and my v is minus cos 3x by 3. And when I multiply both to get my uv, I get minus x cos 3x by 3. And then I go to my integral of v du. I notice that my v equals minus cos 3x by 3. So I pull out the minus 1 by 3 factor with v, and what happens to my, I'll get a plus of 1 by 3, right? I'm pulling the 1 by 3 out of the integral because that being a constant, and now I have cos 3x by 3 times dx, right? So let's write down what our v du part, right? Cos 3x times dx, right? Now, do we know the integral of cos 3x times dx? The answer is yes. So let's go to our next line to finalize our answer. We have more or less arrived at what we want. So I have my first uv part, which I write it as it is, and then my second part, which is 1 by 3 times integral of cos 3x dx, which is nothing but a sine 3x by 3, and 1 by 3 times sine 3x by 3 becomes a sine 3x by 9, right? So, and I'm going to add my constant now. So there we are. We've solved the problem using integration by parts. So like I mentioned earlier, the key here is identifying the right u and v, right? That will help you simplify uv, and also, you know, bring integral of v du also to a much simpler expression, right? So let me highlight my final answer in pink. There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.